Okay. Yeah. Okay. The classes have started again. So now you are in sixth semester, right? So unfortunately, this semester is still going to be online classes only. As you know, previously it was decided to call at least the third year, so offline classes will be there. But later it was actually decided to call all the students. But the classes will be actually conducted online only. Okay, yeah. So anyway, let's hope that by next semester at least we will have some offline classes and all. So 56 have actually joined now. Yeah, it is okay. Yeah. As you all know, the registration has have actually started now. You can actually register. I will actually let know some other information regarding registration for the labs. Okay, maybe in the 1 hour after the class, I will actually send it. Uh, yeah. So I hope everyone had a good vacation. And before I forget, Happy New Year to all. I
Happy New Year.
hope everyone is actually, yeah, thank you. I hope everyone
Happy
is
New Year,
actually
sir.
safe and fine. Yeah. So you had classes in the morning. Previous classes were there.
Yes, sir. We have planned morning.
Okay. Yeah. Okay. Yeah. Uh, so in this, yeah. So yeah, we are having a heat and mass transfer course. We have to take for this semester. So actually, you are having various important courses that are actually being taught in this semester. I think DOM is designs of machinery is actually there. Uh, Manufacturing science is actually there. All many important courses which are related to the mechanical field is actually there. And obviously, one of the most important one is actually the heat and mass transfer, because you know the heat and mass transfer is actually the backbone for thermal stream itself. Yeah, so heat and mass transfer, basically it is actually a very simple subject. Once you actually understand its basic concept, it's actually very simple subjects. Okay, we are just doing everything from the basics itself. So if you are actually very attentive to the classes, and then you will actually understand everything. We will actually try to go as simple as possible, and we will actually try to solve as many problems as actually possible, so the concept is will be actually clear to you. First, we can actually go through the syllabus. Today, we are not going to discuss much. Just we will actually skim through the syllabus and to get an overall idea. From tomorrow, we can actually go for the detailed studies. Can you all see the screen?
Yes, sir.
Yes, sir.
Yes, sir, visible.
Yeah. Okay, so as you can see, it is actually 4 credit courses. So 4 credit means you will be having 4 lectures each semester. So it is actually divided as 3 plus 1, 3 lectures and 1 tutorial basically. But you can see that our syllabus is actually very vast. So we will not be actually able to cover it if you are actually going for only 3 classes per week. So you'll actually try to attend at least one tutorial session at every 2 weeks. Okay. So whatever we are actually being seen in the 2 weeks, we will actually see the problems related to that. We will actually see in one lecture. Okay. So likewise, your understanding will be also going to be very clear. So if you are actually going for the syllabus, first obviously we will having our introduction, and in the introduction we will see what are the different modes. Obviously, it is actually the conduction, convection, and the radiation. Yeah, then we'll actually go for the basic derivations of heat conduction. So it is actually going to be divided into 3 parts. First, we will actually see the conduction part, okay, and then we will see the convection part, then we will see the radiation part. Okay, we will see in detail what are these things in the tomorrow's lecture. We will have a better idea of how we are actually differentiating conduction, convection, etc. for tomorrow's section. So here today we will actually just skim through this syllabus. Okay, and the first we will see the conduction equation. Conduction, it is actually it is actually the mode of heat transfer to solids, basically. Uh, yeah, it is actually due to the molecular activities and all those things. So it is from a microscopic point of view, this heat conduction is actually going to happen. So first we will actually see the basic derivation equations. Uh, so we will actually do this basic derivation equation by taking the basics from the thermodynamics, okay? Which is actually the first law of thermodynamics we will actually use. What is actually the first law of thermodynamics? Can anyone say? It is actually the conservation of what?
Energy
Energy.
supply.
Yeah, good. So from that only we will actually going to start everything. In fact, thermodynamics is actually the basics for this heat transfer. We will see why there is actually this thermodynamics and why we are having a heat and mass transfer subject different from that of the thermodynamics, etc. We will see tomorrow. But you understand that thermodynamics is actually the basis of heat and mass transfer. The concept of heat itself is actually coming from the thermodynamics, right? So from the first law of thermodynamics, we know there are two forms of energy, heat and work. All those things we will actually see tomorrow. So from the thermodynamics only, this concept itself is actually coming. So the basic equations we will actually start deriving based on the first law of thermodynamics itself. And the second law of thermodynamics, is that applicable in heat and mass transfer? Heat transfer? Is the second law of thermodynamics applicable in heat transfer? Can anyone say? What does the second law says of thermodynamics? What are the two statements in second law of thermodynamics?
Kelvin and Clausius
Causes and
statements.
Yeah, very good, very good. So what does both are actually saying? For example, what does the Kelvin Planck statement say?
A
Or what
complete
was the
heat cannot be converted to work, but there should be some
yeah,
sort of
very
losses.
good. Yeah. So what does the Clausius says?
In order to transfer
Without
something from
no
low
work,
potential to high potential, there should be some
Yeah,
work.
yeah. So that means that the heat can be actually transferred only from a higher temperature to lower temperature, right? So that is actually a basic equation. So that is these two are actually the basis of the heat and mass transfer course itself. Okay, so we are using first law for the derivations, and the second law we are not using explicitly, but it is implicitly it is actually understood that heat is actually transferred from higher temperature to lower temperature. Okay, so therefore these two laws of thermodynamics itself is actually gives the basis for the heat and heat transfer equation. Okay, so based on this first law of thermodynamics, we will actually see the total derivation for heat conduction first. Okay, so there are actually different type of coordinate systems, right? Cartesian, polar, spherical, different coordinate systems we will actually see. At least we will see the Cartesian as well as the polar coordinate system, because spherical coordinate system it is there are not much practically. Obviously, there are actually practical uses, especially in case of nuclear heat transfers and all. But we will concentrate mainly to this Cartesian as well as the polar coordinate systems. Okay, so we will see the basic derivation, the full derivation we will actually see. Then we will actually we will actually see a detailed analysis of uh, Cartesian system. Okay, so we will actually concentrating ourselves to one-dimensional conduction equations, because as we are actually going to the two-dimensional, then it is actually going to be two unknowns are actually comes into the picture, heat transfer in x direction and y direction. Okay, the solution for that it is actually a bit tricky, so that's why we are actually not going to see the two-dimensional in this course. Um, yeah, so we will actually concentrate ourselves to the one-dimensional conduction. First, we will actually see in the Cartesian system for various conditions like
Hello,
with
sir.
and without heat generation, with and without varying thermal conductivity and
Hello,
all.
sir.
Yeah, yes.
Sir, you are not recording the lectures.
Okay. So anyway, this is just an introduction. So Yeah. Okay. Yeah. So the same thing we will actually do for polar systems. What is polar system? Polar coordinate system. What is another name for polar system? It's actually cylindrical system. Okay. So we will actually go again for the cylindrical system, because cylindrical system is also very important in many engineering applications, conductions and all. Okay, then we will be having these spherical systems. We will actually go through that if time permits. And then whatever comes into picture is actually the critical thickness of insulation. Okay, so we will actually talk about the insulation first, why the insulation is actually going to be important, and what are its basic concepts, and we will actually go for some derivations and all. Okay, and then we will actually go for the extended surfaces or fins. Okay, yeah, so the fins are actually the surfaces which we are actually using for increase in the heat transfer. Okay, so why it is so, etc., we will actually see once we actually clear on uh, these steady state equations and all. Then we will actually see that for the conduction to happen, and especially for the convection to happen, uh, if you are having a conduction convection system, then in order to have a higher heat transfer, we need to increase the surface area. And all. For that, we are actually going to use this kind of extended surface or fins. Okay, so there are different type of fins. Um, uh, this straight, rectangular are actually there, circular fins are actually there, and we will actually go for a very detailed study of this extended fins. Can anyone say an example for a finned surface? Have you ever seen a fin surface?
So the
Sir,
engine
Radiator.
of
heat
what
sink in
bike?
engines and all.
Radiator.
Heat sink in?
Engines
Yeah, very
or
good.
even refrigerator we
Uh,
have for external fins.
yeah, yeah. For motorcycles, you can actually see that on your engines, you are having this kind of sharp edges and all. So these are actually the fins. You can see these for transformers, and also if you are actually going to open your system CPUs, then there also you can see that on your uh, microprocessors, they are having this kind of structures. Fins are actually going to be there. So these are all used for the better cooling of any surfaces. So we are actually increasing the surface. So whatever the heat within that can be actually easily convected outside. Okay. So once you actually understand the basis of this conduction, it is actually going to be very easy for you to understand, or it is actually easy for you to analyze these fins. Okay. So there are actually various conditions like a fin with a constant temperature, a fin with adiabatic condition at one end. Likewise, there is actually various boundary conditions are actually there. All those things we will actually see. Okay, so then we will actually go for a transient heat conduction. Okay, so in a transient heat conduction, again it is actually a bit tricky, because again two variables are actually comes into the picture. So this is again in one dimension only. We will actually see, even though it is one dimension, we will be having now two parameters. So the time as well as the x direction. Okay, so time and the length in one direction, it is going to be there. Okay, so it is actually a bit tricky, but we are actually not going into very much detail for this also. We will actually see the symbol surfaces and the symbol analysis also. Okay, so you can see that numerical problems are actually there for all the sessions. So these numerical problems we will actually see in the tutorial sections. Okay, so during the lectures we will not see explicitly these numerical problems. So we will actually collect everything, and we will actually see for a particular tutorial section, we will actually solve the problems for each cases. So that's where we are having this conduction problems. So here, one a steady state one-dimensional heat conduction in Cartesian system we will actually see. Then we will actually see in polar systems. Then we will actually look into the insulation, then extended surface, and then we will actually see the transient or unsteady condition. Okay, so you can see we are actually covering in very much detail the conduction heat transfer equations. Okay. So after the conduction, we will actually move on to the convection cases. So in the convection, we know it is actually due to the bulk movement of the fluids and all. So therefore, the fluid mechanics or the it is also comes into the picture. Okay. So whatever you actually studied in the second year, fluid mechanics, that also comes into the picture, especially this boundary layer theory and all those things. Okay, and we have to see the Navier-Stokes equations, energy equations, and all those things. We will try to derive ourselves also one more time these Navier-Stokes equations and all. But you should be actually familiar with all these terms. Okay, so I just all of you to go through this fluid mechanics, not at least whenever we are actually going for this forced convection thing. Okay, yeah. So we will actually see the boundary layer theory and velocity and thermal boundary layer actually going to be the importance of Prandtl number. Then we will actually see the governing equations, continuity as well as the Navier-Stokes. You have already seen in fluid mechanics. Then we will actually extend it to the energy equations also. Okay, so this also we are actually going to do this energy equation. This also we are actually going to do uh, by taking the first law of thermodynamics, which is actually the conservation of energy. So based on that only we are actually going for this. Okay, so then we will actually try to solve some integral or analytical solutions. Okay, so yeah, then we will actually go for this internal flows. Okay, it's flow through pipes and all. And external flows also we will actually see forced convection over cylinders and spheres. So likewise, simple problems we will actually going to see. So then we will also see the free convection, which is actually the buoyancy, where we are having this buoyancy effects comes into the picture. Okay, so all those things we will actually see. So the forced convection as well as the free convection. So the this actually covers most of this convection part, and also we are having heat exchangers. So that also comes into this forced convection part. Obviously, it is actually different section itself, but with the basics of the convection, we will have a better idea of this heat exchangers. Okay. The heat exchangers means where we are actually transferring the heat from one fluid to another fluid. Okay, so that is actually known as heat exchangers. So there are actually different type of heat exchangers. So whatever the type heat exchangers, so there are actually some basic calculation which can be actually used for any type of heat exchangers. Okay, so that we will actually see like LMTD methods, effective NTU methods. So likewise, various methods we will actually see for heat exchangers, which can be actually used for any type of heat exchangers. We will actually see what are the different type of heat exchangers in this classification session. Okay, yeah. So that actually yeah. So for the force convection, it is actually very important session in heat transfer, because wherever you are actually talking about cooling of a surface, this force convection comes into picture. Okay, so you can hear that whenever you are using your laptop, you can see that hear that after some time you can actually hear some noise. What is that noise? Can anyone say? Even if it is your desktop or even if it is your laptop, sometimes you can actually hear a noise. What is that noise?
Working
Sorry,
of
heat
that fan,
dissipation.
sir.
Yeah, so it is actually the cooling of your system. Okay, so some fan is actually going to be there inside. That fan is actually going to take up some air from the inside or air from the ambient, and it is actually going to blow that air over some surfaces. So what is basically happening? So basically happening is the due to the convection, the heat is actually being transferred from the heated surfaces, whatever inside your laptop or your computer, and that heat is actually being rejected towards the ambient. Okay, so that is actually a very good example for this convection heat transfer. Okay, so likewise, various methods are there. So yeah, so what are we actually just said? The cooling of your cooling of the engines using fins. Okay, so what happens is that due to the fins, the surface area is actually going to be increased, And whenever you are actually passing your motorcycle at 40 meter per second or 50 kilometer per hour and all, so there is actually going to be a flow of air over your engine, right? So that is actually the convection. So there is a bulk movement of air over your fin surface is actually going to happen. Okay, so therefore that is actually going to take up some amount of energy, or some amount of heat, and it is actually being given to the ambient. Okay, that is actually the forced convection. Okay, it is actually of immense importance, this forced convection as well as the free convection. Basically, the convection part, it is of immense importance. Okay, so everywhere, if you are actually going for these power plants, thermal power plants, you have actually seen, right, in your thermodynamics classes, as well as your turbo machines and all. So everywhere, this convection is actually what happens. So you are actually having this uh, somewhere we are having a boiler. What is actually happening inside the boiler? So inside the boiler, you are actually having the flow of gas, hot gases are actually flowing, right? So inside the boiler, you are having various tubes. Inside the tubes, what is actually going to happen? Inside the tubes, you are actually passing the water, right? So that water is actually absorbing the heat from the flue gases, and it is being converted to steam. So there the heat transfer is actually happening. What heat transfer? It is actually the convection heat transfer, because the bulk movement of the liquids are actually going to be there. Okay, bulk movement of the fluid is actually going to be there. Outside it is actually the gas, and inside it is actually the water. Okay, so you can see that there the convection is actually happening, and there it is actually a big heat exchanger also, because heat is actually being transferred from one fluid to another fluid. Okay, so with the basic understanding of the heat convection, we will actually analyze this kind of heat exchangers also. So this convection, it is actually of importance everywhere. Okay, so we will actually see in detail what are these convections and what are its basic principles. But again, convection, we cannot actually analyze the convection for each and every part, because in tomorrow's lecture we will see that the heat transfer coefficient, which is actually comes into the picture, it is actually depend upon so many conditions. Okay, we cannot actually cover all the conditions in any of the classes or any of the textbooks. Okay, so that's why we are actually going for the numerical problems. So those things we will actually see tomorrow. Okay. So therefore, this convection is also of very immense importance. The conduction also, it is actually of very high importance. Okay. Then we will actually see the third mode, which is actually the thermal radiation. Okay, so thermal radiation, as you know, it is actually there everywhere around us. It is actually one of the biggest source of energy for a planet or in the universe itself. Okay, or it is not the source; it is actually the mode of transfer of energy in all universe. Okay, so we will see the fundamental principles, and obviously for thermal radiation, we will not go in the very much details. Okay, we will actually restrict ourselves to the basics, fundamentals, principle. We will see what are the different type of bodies, and we will actually see what are the different theories, whatever we are actually talking about. Okay, so what are different theories we can actually use for the calculations. Okay. Yeah, for the basic like emissivity and Kirchhoff's laws, we will see what is actually the view factor. We will see the methods for calculating the view factor, and obviously we will see how we can actually calculate the heat exchange between two bodies due to the radiation signal. Okay, and also we will see the radiation shielding and all those things. So radiation is also very much important in many of the cases, especially when we are actually talking about high temperature bodies. Okay, because in a regular low temperature bodies, what happens is that the conduction or convection mainly is of more than convection heat transfer is more than that of this thermal radiation. So in many of the cases, we usually neglect this thermal radiation, but as the temperature is actually going to be increasing, the radiation effects are actually going to be increasing, because we will see that the thermal radiation, it is actually depend upon the fourth power of the temperature of a body, whereas conduction and convection, it actually depends upon the first power of temperature of a body. Okay, so therefore, as and when the temperature of a body is actually going to be increasing, the effect of radiation is actually going to be increasing exponentially. So therefore, yeah, and also when we are actually talking about the space applications and all, obviously there is no convection over there. So there, radiation only is actually going to be there because the radiation doesn't need any medium at all. Okay, don't worry, we will actually cover everything in detail. So right now, I'm just giving you a feel of this course. Okay, yeah. So this is actually the basic course, and last we will actually see some basics of the mass transfer because mass transfer you can see we are actually giving a very small portion. Why? Because the heat and mass transfer are very much analogical. So whatever we are actually talking about the heat transfer is actually applicable for mass transfer also. And we have to just see only some laws. Okay, so whatever the analysis we have actually done, that is actually applicable for mass transfer, the whether it is actually conduction or convection, the same kind of analysis we can actually do for mass transfer also. Okay, so once you actually understand the heat transfer and some basics to convert the heat transfer to mass transfer, then it is actually then you can actually easily understand any of the mass transfer problems. Okay, so therefore we will actually see some basic definition, and you can see only a very small amount is actually given over here as mass transfer. But as I said, once you actually understand the heat transfer and how we can actually convert the ideas of mass transfer, heat transfer to mass transfer, then it becomes very clear to you. Okay, so that actually gives us a overall view of this mass transfer or the course. Okay, so first we will see the conduction and then convection and then radiation. So we will go in that order. And regarding the textbooks, we will actually mainly concentrating or we will actually mainly referring to this Incorpora debate. Okay, it's actually very excellent textbook. Okay, most of the materials whatever we are actually going to be discussing, it is actually taken from this. But there are actually so many textbooks are actually available outside, and JP Holman is actually one good textbook, and a heat transfer, a practical approach by Sanjal is actually there. That is also a very excellent textbook. Okay, yeah, this Alan Chapman is actually going to be a textbook. So like this, various excellent textbooks are actually going to be there, but we will be mainly concentrating on this one. But you can actually refer to any of the textbooks. Okay, and problems also you can actually take from you. You must actually do as much practical problems are actually possible. Okay, in Essential and all, you can see excellent practical examples are actually going to be there. In Copper also, the examples are all practical. You will get a very good feel of this heat transfer from these practical problems. Okay, so I suggest all of you to go through these problems also. Obviously, during the tutorial sessions also, we will actually try to see or try to solve as much numerical problems are actually possible. Because when it comes to the exams, uh, I'm I don't know for sure right now, but usually we can see that 80% of the questions will be actually this kind of practical problems only, because there is nothing much to ask in the theory part. Okay, oh, and obviously this time we are having this open textbook examination, so there is no point in asking direct questions or something. So obviously, if we can actually take something here and there, and if we can actually obviously add some derivations and all. If we change some boundary conditions, obviously the whole derivation is actually going to be different. Okay, instead of a constant temperature, if you are having a slab or something, instead of a constant temperature, if you're actually asking about a convective heat transfer boundary condition, all your solution is actually going to be different. Okay, so likewise some derivations might be actually going to be there, but mostly the numerical problems will be actually there for the end exams or any of the exams. Okay, so yeah, so that is actually the overall view of our syllabus. So from tomorrow we will actually go in detail of what are the different type of modes of heat transfer, its governing laws, applications, and all those things. Okay, yeah. So yeah, and I'm actually thinking like this time we will actually go for this whiteboard lectures itself. Let me see. Means maybe we can actually try for 2 3 lectures as a whiteboard lectures. If the time we are taking is actually too high, then we will go for the PPTs. Okay, because the issue is that here you can see everywhere we are having some derivations, some equations are all going to be there. If I am actually simply going to give it into the PPTs, you guys will never write it down. So to get a feel for the derivations, you have to do it by yourself. Then only you will actually see. Okay. So what I'm actually planning is whiteboard we will actually use. So be ready with this one notebook and pen and all. So we will derive this, or we will actually do the derivations by hand itself. So all of you will get a very good feel for this. Okay. Otherwise, you will be actually simply sitting and you will simply listen, and you will not get that much feel for them. But obviously, if the time taking is actually, or time too much time is actually taking, then we will see where we can actually try to go back to the PPTs. And why I'm actually doing is there are so many PPTs available in uh, net itself. Okay, for all any of the heat transfer, because this is actually a very common subject, very important subject. So PPTs are actually available in net also. Okay, very good, excellent PPTs by various IIT professors are also available in net. Okay, that's why I thought like we can actually go for this whiteboard itself. Whiteboard means in screen only we will actually write it. Okay, we will see how it is actually going. If it is very clumsy and if it is actually very difficult, then obviously we will go for the PPTs. Okay. Yeah. So you must attend all the classes. It is actually very conceptual oriented. That's what I am actually saying. Okay, it's actually very conceptual oriented. So once you actually attend all the classes, this concept will be very clear, and it's actually going to be very simple subject for you. Once you actually miss all the basic concept, then it is actually going to be very difficult. Okay. Yeah. So try to attend all the classes as possible. And regarding the exam pattern, like we had for mechanical measurements, uh, I think this time also it is online. So 30 for a midsum, 40 for end-sum, and 30 will be actually the internal evaluation. Okay. So we will put 10 for minor, 10 for minor 2, and then again 10 for some assignments or something that we will actually see. Okay, or 15, 15 for us minor 1 or minor 2, or we can have 3 or 4 minors also. So that we will actually decide later. Okay. Yeah. So for tomorrow's lecture, at least be ready with some a note and pen and all. So we will actually try to, yeah, we will actually start the tomorrow's lecture with the different modes, this introduction part, different modes, governing laws, applications, etc. Okay. Yeah. So any doubts, any suggestions, anything? Okay. Okay. So if nothing to discuss, then we can actually close the class for today. Then we can actually see tomorrow. Tomorrow same time, right? 11:30 to 12:30. Okay. 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 Then have a nice day to all.
Thank you, sir.
Thank you, sir.
Thank you, sir.